आगे बढ़ते हैं, ठीक है. Let's move to the concept of organic chemistry. Yeah, organic chemistry is very interesting, guys. It is like a puzzle. It's got lots of things lying here and there. All you need to do is understand all of those things, and the puzzle becomes super easy for you. So the concept that I'm going to tell you today is about enantiomers, is about chiral carbons. Okay, some things are there which can't be explained in the remaining half an hour that we have. So what we'll do is we'll try to simplify things as much as we can, but the way I will teach you the concept will make you capable of solving questions that come in JEE. Good enough, guys? Okay. So I'll again launch a poll which asks you this particular question, which is, okay guys, come on, I'm waiting for your votes. 50% of you have voted. Come on, quick. Okay, 80% of you have voted, guys. I'm going to close the poll in 5, 4, 3, 2, and 1. Okay. So a lot of you people are giving me so many questions, guys. I will attend the questions in the last part of the webinar. One more thing, I will also tell you my phone number at the end of the webinar. One more thing, that don't worry, we will revise everything at the end of the webinar. Okay? So guys, all I wish for you to do is stay tuned, just half an hour more, and you will go away with another concept that will help you enable score more marks in JEE, and that's what we are here for. Okay? So what happens is when you have a source of light, like a normal light bulb, this is a very normal, usual light bulb, NORMAL, super normal light bulb. The way it spreads light out, if you can see my image in your tiny little screen, yeah, see my image. This is a light source. This is the light that is throwing out. It is going to be thrown in all of the directions. Okay? Now to do an experiment, I am a scientist. I am an organic chemist now. I am in my laboratory. I have to do some experiments. To do the experiment, I don't want the light in all directions. I want the light only in one direction. Okay? This was all directions. If you can see my image, this is just one direction now. Okay? To do this, to take my light that is in all directions and convert it to one direction, I need something that is called a polarizer. Yeah. So as you can see, this was normal light that went into the polarizer. It became light that was only in one particular direction, and I am a scientist. I'll give it a cool name. I'll call it plain polarized light. Okay? So don't worry too much about how this happens. Let's focus on what happens right now. Okay? Because this is not that important to understand. What is important is what I'll tell you. Okay? So यहाँ से light आई. It was normal light. You took it only in one direction and you called it plain polarized light. Now this is where organic chemistry comes in. ठीक है? मैं यहाँ पे green pen ले लेता हूँ, थोड़ा बड़ा कर देता हूँ उसको, and I'll make this डब्बा here. This sample tube containing a chiral compound. All right, this chiral thing is what we will focus on today. What happens is, lots of years back, like in 1800s, there was a French scientist called Jean-Baptiste. I don't remember exactly what year it was in, but it was something around 1830s. Yeah, what he did was he was experimenting with some compounds, and he felt like doing this particular experiment that is in front of your screen. He took that compound in a transparent box and put it in front of plain polarized light. What he experienced was something that was super fascinating. If you again see the image on my webcam's image, if you can please concentrate on it. This was the light initially. You turned it into one direction. Now when you took this light and passed it through this material, let's say this is the material, this is the chiral compound. When you pass through it, the light had now changed its direction. All right, the light had now changed its direction and it was rotated into some other direction. Okay, so just to make it a little more mathematical, if let's let's say this was at 90 degrees first, okay, to one plane, if the light was 90 degrees, now the angle has reduced and it has become, let's say, just 60 degrees. This is what my friend from 1800s, John Baptiste, found out, all right? And then after a lot of research of around hundreds of years, okay, it was found out that when you take chiral compounds, CHIRAL, when you take chiral compounds, those compounds have the tendency, those have the ability to turn the plane polarized light into some other plane. Okay? They can change the angle of the light. It's something like if someone throws a ball at you and you hold the ball and throw it in some other direction. It was so damn fascinating that a tiny little compound, a tiny little collection of molecules could do it. Yeah. Now, what we will do is we will focus on what this chiral compound is. Okay? What is a chiral compound? The chiral compound comes from organic chemistry. Okay? And in organic chemistry, we have compounds of carbon. We all are familiar with it. If I think in 9th or 10th class, you have studied the chapter of carbon and its compounds. Yeah. So it comes from carbon. Now, a very basic fact about carbon that all of you already would know. If you don't know, just stay with me. That carbon forms bonds with a valency of 4. Yeah, you definitely have seen the structure of acetic acid. Okay, carbon has a valency of 1, 2, 3 and 4. Okay, in this particular case, it is bonded to 1, 2 and 3 different types of groups. Okay, carbon is bonded to something, whatever it is bonded to, we don't want to see that, we will call them groups. Okay, so generally the types of bonds that carbon forms are of this variety: C with A, with B, with X and D. I am not writing C instead of X because we already have a carbon in between, but A, B, C, D are random groups, okay, random elements, random things that are attached to carbon. Okay, so keep this in mind, carbon can form 4 bonds at once, and when carbon is bonded to 4 different atoms, only then we will be able to see the condition of a chiral carbon. Okay, so the first thing that is required for a carbon to be chiral is that it should be bonded to 4 species. Okay, 4 different groups. We will see what the different groups are like, okay, how they are different. Okay, now the second thing that we need to see is that the carbon is tetrahedral in nature. Okay, now since I have shared my screen with you, I believe you guys can see this particular thing here. This on the screen, this rotating structure is what a carbon bonded to 4 different things would look like in 3D. In 3 dimensions. This is super interesting, guys, so please stay on it. The thing in the middle, where my mouse is pointing right now, is the carbon. And these yellow, green, red and white things that are attached to it are the A, B, X and D. This is what it looks like in 3D space. Okay guys, this is what a carbon which is bonded to 4 different groups looks like in 3D space. Now, the way I would draw that structure on paper is something like this. Okay, I will put A, B, I will put an X which is behind the plane, and I will put a D which is in front of me. Okay, this is just a notation, guys. It is something like A and B, X and D. If you can see the image in my webcam, if this is your carbon, these are A and B, okay, and this is X and D. This is just a notation of putting 3D to 2D. Again, you don't need to worry about this. Now what happens is, if I take a mirror in between, okay guys, please stay around with me. Abhi, it might seem complicated, but then I'll tell you a shortcut which makes it super easy. Okay, just stay with me for this. Let's take a mirror in between and then take a mirror image of this compound. So मैं क्या करूँगा? I'll just take a mirror image. We've all been using mirrors for like since we were born. This is something that will get formed. Okay, this is the mirror image. Now I'll go back to that page that I had. Okay, this was the 3D carbon. This was my ABCD. ये वाला जो, if you can see me rotating this particular thing here on my screen, right? This was my ABCD in one particular form. If you see here, this one, ठीक है? इसका diagram बना दिया this. This one was its mirror image. Okay, this particular case was the mirror image. Now, if I try to take this form, which was the original form, this form, which is the mirror image form, assume that I have taken both of those forms, if you see in the webcam. Now I'll try to see whether they are same or not. Okay, I will try to see whether I can rotate the mirror image in such a form that it can fall directly onto the initial image. Whether it can or whether it not is the question here. And guys, if 4 groups on carbon are different, what you see is this. There is no way to rotate, turn, or orient the two models to superpose upon each other. They just cannot fit. If you want a simple example, take one hand and take the other hand. This particular hand, my left hand, if you can see in the webcam, left hand is a mirror image of the right hand. If I try to superimpose them like this, it's not happening. If I try to take it like this, okay, the fingers coincide, but my nails are now in the opposite directions. Yeah, my nails are not like this. My nails are in the opposite directions. So this means that I am not able to superimpose these two structures on each other. Okay, I'll just write one sentence here. Don't worry if it is too complicated. The shortcut is coming very soon. Non superimposable mirror images. ठीक है guys, non superimposable mirror images. Now, whenever you have a carbon which has a mirror image and you can't superimpose the mirror images on each other, these things are called chiral. All right, so the crux is chiral equal to asymmetric. Okay, and if I say achiral, this is a symmetric, which means I can superimpose its mirror image. Let's just focus on chiral. You don't have to even think about what I told you. All you need to see is carbon with 4 different substituents. All right, carbon with 4 different substituents, that is called a chiral carbon, and this particular type of carbon will show you the property of being able to rotate the plane polarized light. All right, so all you have to see is carbon with 4 different groups. That's all. 4 different groups is what you have to see. Now let's jump on to the practice. I'll call this question number 1. I'll call this question number 2. Let's read out question number 1. Amongst the following compounds, the optically active alkane having the lowest molecular mass is. Optically active means something that can rotate the plane of light, right? And alkane is basically the name for a carbon chain. Which one is the optically active alkane? All you need to see is which one of these has a chiral carbon. Okay, all you need to see is which one has the chiral carbon. It is 9:46 right now. This question is super easy. I'll give you time till 9:48 p.m. Okay, take time till 9:48 p.m. I'll launch a poll and see what your answers are. For those of you who are wondering if they can revise whatever is in the webinar, don't worry guys, we have to cover this in 1 hour. But after the webinar, you will get an email which will have the recording of this webinar. Okay. चलो और देखते हैं, बहुत लोगों के सही आंसर्स आ रहे हैं मेरे को. डोंट वरी, आफ्टर वी सॉल्व दिस क्वेश्चन वी विल easily be able to solve this answer. Okay. चलो मैं पोल लॉन्च कर देता हूं. Here you go. Okay, a lot of votes have already come in. I am getting a very good response from you guys. 70% of you have already voted. Come on, guys, quick, quick, quick. Okay, I'm going to close the poll now in 5, 4, 3, 2, and 1. Chalo. So the results are as follows. Most of you guys are saying that C is the correct option. Then some of you are confused between A and B. Okay, cool. I'll now show you how to solve this question. Okay, so क्या करेंगे हम? Let us see the first particular case. ठीक है, optically active ढूंढना है अपने को. We have to find what is optically active. Now with the help of this particular question I'll tell you how to do this. CH3 है, this one, it has one chain attached to it which is here, and then you have 3 hydrogens. We saw that when a carbon is associated to 4 different types of things, only then it is chiral. Yeah, so this carbon is not chiral. Similarly, this has 2 hydrogens, this carbon is not chiral. This also has 2 hydrogens, not chiral. This has 3 hydrogens, not chiral. Yeah, only when all 4 things associated to a carbon are different, only then it will be chiral. Similarly, this is not chiral, this is not chiral, this is not chiral, this is not chiral. Let us see this. Okay, one hydrogen, one long chain here, one CH3, two CH3. Yeah, these two are CH3s, same things attached on one carbon. Hence, even in B, this thing is not chiral. So the first one was not chiral, second one was not chiral because there is no carbon which has different things associated to it. Let's see the third one. This is not chiral. This has C2H5. Okay, C2H5 looks something like this. CH2CH3. This is again not chiral. ठीक है, तो ये भी chiral नहीं हुआ. Hydrogen of course can't be chiral. This is a triangle of carbons. It is again not chiral. What you have in the center, this one, right? It has 4 different groups attached to it. 1 group, 2 group, 3 group, and 4 groups. Yeah, 4 different groups of carbon attached to it. This one is chiral. I'll put a star mark here. If you see the fourth one, this is not chiral, this is not chiral. This carbon is not associated to 4 different things. It is just associated to 2 different things, one chain and one another carbon with triple bonds. We said that when a carbon is associated to 4 different things, then only it is chiral. So this compound is also not chiral. The answer is C, and majority of you got the answer as C. ठीक है, quickly solve करते हैं. Second question, 9:50 right now. Let's take time till 9:52 p.m. and I will take your answers in a poll at that time. Guys, for those of you who are a bit confused, don't worry. This was just a glimpse. Yeah, this was an attempt to condense a lot of information in 1 hour. If you think you need more time to understand these concepts, whatever I've told you in this 1 hour will actually be taught to you in a span of 4 to 5 classes. All right, so those of you who are a bit confused, don't worry, we will cover all of this in the full course. ठीक है, and I've tried to make the concepts easy for you so that you can understand them right here itself. ठीक है, so I'm getting a lot of good responses in the questions box. I'm getting actually a lot of responses in the questions box. ठीक है, कोई बात नहीं, फटाफट से मैं पोल लॉन्च कर देता हूं. Okay, so among the following structures 1 to 4, which one? Basically it is asking what is true. Yeah, very simple. It's asking whether they are chiral or not chiral. All you want to see is those specific carbons which are bonded to 4 different things. ठीक है, and I'm sure you guys will perform better this time. Okay, I'm actually getting a very good response. Brilliant job, guys. Awesomeness. Sheer awesomeness. Okay, 80% of you have voted. I am going to close the poll in another 5, 4, 3, 2, and 1. बढ़िया है भाई, poll close कर देते हैं. चलो. So the answers that I've got are something like this. They're on your screen right now. Most of you say B, some say C and D, and some say A. ठीक है, चलो देख लेते हैं कि चल क्या रहा है. If I focus on compound number 1, this is C2H5, not chiral. This is C3H7, again not chiral because they are long chains with carbons having multiple hydrogens. CH3, again not chiral. If you look at the one in the middle, this one, this is a chiral carbon. It has CH3, C2H5, C3H7 and hydrogen. 4 different things attached to it. So I'll mark a star here. Second case, if you focus on this particular carbon, it has 4 different groups. CH3, this long thing, again this C2H5 and an H. All right, very simple. Yeah, again this one is a chiral carbon, so what I'll do is I'll put a star mark here. Third one, hydrogen, 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 positive charge. 3 hydrogens, guys, same, not a chiral carbon. If I look at this one, CH3, C2H5, again C2H5, 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 2 C2H5s on the same carbon. That implies all the 4 are not different. That's why this is also not a chiral carbon. Hence, the correct answer is only 1 and 2 are chiral compounds. Super simple, guys. You've studied all the structures in 10th standard, I'm sure. So in 11th, now you can interpret the structures as well. You can see whether things are chiral or not. चलो आगे बढ़ते हैं.